Today's video is all on naming acids and bases, just to make sure we can name them correctly. So there's two types of acids that we're going to look at. There's binary acids and polyatomic acids. Now, first, just to define that, binary acids are acids that will include hydrogen and then one other element. So it's always going to be H and then just one element. So you can see here is HCl, hydrogen and chlorine, and here H and F, hydrogen and fluorine. So that's what a binary acid is, hydrogen and one other element. A polyatomic acid, that is going to be hydrogen and then a polyatomic ion. So at any time, generally speaking, it's going to be hydrogen, and then you'll recognize that there will be two or more elements connected to that hydrogen, therefore allowing you to identify that it is a polyatomic ion. So that's your first step in naming an acid, is recognizing whether it's a binary acid or a polyatomic acid. So we're going to look at binary acids first and the rules that go with those. So the first thing with binary acids is you always add the word hydro to the beginning. So if we look, you always want to add the word, losing control. Always want to add the word hydro to the beginning. So if we look at our example here, I'll do this one. So the first step we're going to do is always add hydro to the beginning. That's always going to happen. Our second step, we want the root of the anion. Now remember, the anion is what's negatively charged. It's never going to be hydrogen. Hydro represents hydrogen. The root of the anion is always just going to be whatever that second element is. So hydro, and then chlor would be kind of the root of that anion because we have chlorine. And then we want to make sure we end it in ic, so hydrochloric. So instead of ending it in hydrochlorine or hydrochlorite or hydrochlorate, we're ending it in ic, so hydrochloric, and then you just add acid as the second word. So hydrochloric acid would be our first example. Let's look at our second example. First thing I always do is begin with the word hydro, and then I look at what my anion is, in this case fluorine, and I know that I have to end it in ic, so I'm going to cut off the ine at the end. So hydrofluor, I think it keeps going off, hydrofluoric, IC, and then I always have to add acid as the second word. So those are my two examples, hydrochloric acid and hydrofluoric acid. Now let's look at our polyatomic acids, excuse me. There's two rules for polyatomics. You have to recognize how that polyatomic ion ends. If the ending of the polyatomic ion is ite, like nitrite, then you have to change the name or change the ending of the acid to ous. If the end of that polyatomic ion, if it ends in ate, then you have to change it to ic. One thing you'll notice about polyatomic acids that is different from binary acids is we are not adding the word hydro to the beginning. We are just replacing the ending and then adding the word acid as a second word. So let's look at this example. This is an example that ends in ite. So this is nitrite. NO2 is nitrite. So that is an example that ends in ite. So we have to change it to us. So we don't add the word hydro. All we do is and so it would normally be trite. We delete the ite and put ous. So nitrous, and then just add acid. So that's not too bad. Just take off the ite and then add ous and then the word acid. Our second one here is an example. SO4 is sulfate. So that means it's ending in ate. So we need to take this and we need to, so normally it would be sulfate. That's the typical polyatomic. We're taking off the ate and adding ic. It's going to be sulfic acid. Just like that. You could also, you'll see it sometimes as sulfuric acid, but this sulfic acid would also be correct. Sulfuric acid would just be another way to say it. So sulfic, let me get that. Sulfic acid or sulfuric acid, We're taking off the ate and we're adding IC or ic there at the end, and then we of course are adding the word acid. So those are our two types of acids that we're going to name, the polyatomic and the binary. Naming bases is extremely straightforward, and there is only one rule. You name the cation first and then add the word hydroxide. Not complicated at all. So here we've done this plenty of times when we were in our naming unit. Here you have sodium, and then you just add the word hydroxide. Hydroxide. There we go. I got it. And then our next one, you have lithium, so it'd be lithium hydroxide. And then our last one, you have magnesium, so it'd be magnesium hydroxide. Magnesium hydroxide. Okay, so bases, very straightforward. You're just naming it how it looks. You name the cation first, and then just add hydroxide to the end. So very straightforward. As you get deeper into acids and bases, when you look more in depth into them, you'll see that there's different types of acids and different types of bases, and the naming can get a little more complex. But for our purposes, sodium hydroxide, just naming the cation and adding hydroxide, and then for the acids, just hydrochloric, hydrofluoric, with just the binary, and then with the polyatomic rules as well. So you got to make sure you can recognize when we have a polyatomic and if it ends in ite or ate, and then you should be good. So that is naming acids and bases. Farewell.